Hello, this is Tim Smith, the Academic Support Coordinator for St. John's River State College, St. Augustine campus. This video on applications of trigonometry, law of sines, law of cosines, is designed as a study aid and supplement to the math tutoring services offered at St. John's River State College. It is recommended that students view the video Trigonometry and the Unit Circle before watching this video. In this video, we will be discussing the law of sines and the law of cosines. In previous lessons, we learned how sine and cosine apply to right triangles. With many trigonometric applications, however, we don't always face the simplicity of right triangles. The law of sines states that in any triangle, the lengths of the sides are proportional to the sides of the opposite angles. For any triangle ABC, where side A is opposite angle A, side B is opposite angle B, and side C is opposite angle C, sine A over A is equal to sine B over B is equal to sine C over C. We prove the law of sines by considering the area of the triangle, which is equal to 1/2 the base times the height, remembering that the height must be measured perpendicular to the base. For the given triangle, let's start by selecting side A as the base. To solve the area problem, we must create a vertical line H perpendicular to side A. We'll designate this height h1. Knowing our trig function, sine B will be equal to the opposite over the hypotenuse, or h1 over c. Solving for the height, we get h1 is equal to c sine B. Therefore, the area will be 1/2 A times C times sine B. The same area can be calculated by creating a different height from the other two angles. h2 is equal to A times sine C, which would give an area 1/2 A times B times sine C. h3 is equal to B sine A. The areas from this measurement would be 1/2 B times C times sine A. These areas will, of course, be equal and can be expressed by the following equality. If we simplify by multiplying 2 over A times B times C, we are left with sine A over A is equal to sine B over B is equal to sine C over C. In this example problem, we have a scalene triangle with two angles and one side identified. Using law of sines, we can solve for the unknown side x. The first thing we should remember from our geometry lessons is that the sum of the three angles of any triangle must be 180 degrees. So we set up a sum of 52 degrees plus 70 degrees plus the unknown angle is equal to 180 degrees. Therefore, angle C is equal to 58 degrees. By noticing that the given side is opposite angle C and the unknown side is opposite angle A, we can set up our equality using that portion of the law of sines. Sine A over A is equal to sine C over C, or sine 52 degrees over x is equal to sine 58 degrees over 26.7 feet. If we solve for x, we get x is equal to 26.7 feet times sine 52 degrees over sine 58 degrees. These angles do not appear in the unit circle, so we can go to our trigonometric tables to get a decimal approximation. Sine 52 degrees is equal to 0.788, and sine 58 degrees is equal to 0.848. Completing the arithmetic, we arrive at side x is equal to approximately 24.8 feet. We can also use the law of sines to solve for an unknown angle. In this case, we are given the obtuse triangle ABC with the measures of two sides and only one angle given. We see that the given angle A is opposite one of the known sides, and the unknown angle B is opposite the other known side. Therefore, we can use sine A over A is equal to sine B over B. Applying the known values, sine 110 degrees over 28 is equal to sine B over 15. Referencing our trigonometry table, we see that sine 110 degrees is 0.9397. So we replace it in the equation. Multiply both sides by 15, giving us sine B is equal to 0.5034. We can now apply the arc sine to both sides and look again at our chart. Here we pick the closest value on the interval from 0 to 90 degrees. So angle B is approximately equal to 30 degrees. With two angles now known, we can use the sum of angles to solve for angle C, which equals 40 degrees. Let's now go back to our law of sines and solve for side C. Sine A over A equals sine C over C. Sine 110 degrees over 28 equals sine 40 over C. Solving for C, we get C equals 28 sine 40 over sine 110. Retrieve the values off the trigonometric chart. Sine 40 equals approximately 0.6428 and sine 110 equals 0.9397. Complete the arithmetic, we arrive at C equals approximately 19 units in length. The law of cosines states that the square of any side of a triangle is equal to the sum of the squares of the other two sides, minus twice the product of those two sides times cosine of the included angle. For any triangle ABC, where side A is opposite angle A, side B is opposite angle B, and side C is opposite angle C, the following three equalities can be made. A squared is equal to B squared plus C squared minus 2BC cosine A. B squared is equal to A squared plus C squared minus 2AC cosine B. And C squared is equal to A squared plus B squared minus 2AB cosine C. To prove the law of cosines, first we align a triangle on a coordinate plane such that angle A is located at the origin and side C corresponds to the x-axis. With angle A located at 0, 0, angle B will be located at C, 0, and angle C will be located at B cosine A, B sine A. For the distance equation, we derive the following. A squared is equal to B cosine A minus C quantity squared, plus B sine A minus 0 quantity squared. We next FOIL out the squares, giving us B squared cosine squared A minus 2BC cosine A plus C squared plus B squared sine squared A. Now let's group terms. B squared times cosine squared A plus sine squared A minus 2BC cosine A plus C squared. Since cosine squared A plus sine squared A equals 1, we are left with A squared is equal to B squared plus C squared minus 2BC cosine A. In this example problem, we are asked to calculate the length of the unknown side of the prescribed triangle using the law of cosines. In this case, the unknown side x is opposite angle A. The other two sides are given. Therefore, we can use the law of cosines. A squared plus B squared plus C squared minus 2 times B times C times cosine A. Replace B and C with the sides values provided, and the angle A is 39 degrees. Take the squares of the two side values and multiply 2 times 21 times 42. Add 441 to 1764 to get 2205. We reference our trigonometry table to find cosine 39 degrees equals approximately 0.7771. 1764 times 0.7771 is 1371. 2205 minus 1371 equals 834. Remember, the law of cosine starts with a squared, so the square root of both sides, and find A is approximately equal to 28.9 units. If you have further questions on this or any other math topic, or wish in-person tutoring, please consult the Academic Support Coordinator on your respective campus. Thank you, and good luck with your studies.